Well, hi guys. So this is lesson two in our workbook here, and the notes that we're going to be doing today with this lesson is what is speed. And so our agenda on the right-hand side is we're going to go through just a real brief mathematical warm-up here to solve a distance problem, and then we're going to do just a little bit of reading on speed, just to get our feet wet with learn some variables, just some ideas on speed. We're going to go through some graphing relationships with speed. We're going to do some relationship practice. Just briefly, I'm just going to kind of guide you through it so you can do some individual work, and then we'll have our final thoughts. So the first thing here is our bell ringer, our warm-up. Is solve the problem. We have our equation here, which is distance. Ooh, let me go back here. Let me get our little pencils down there. We have distance divided by time is equal to speed. So we have our distance is equal to 20 meters here, and our time is equal to 2 seconds. So if I'm doing that, solving this problem, I actually like to do it a little bit backwards here. I like to go S is equal to, you put the variables first, the letters is D over our T, and then that's equal to, what do we have here? We have 20 meters, and then we're divided by 2 seconds. All right, so how many times does 2 go into 20? We have it where the S would equal, and I'll use purple for this, 10 meters dash seconds. And that is our answer for that. So nice, just simple problem, but simplicity is really important when we go through mathematical equations. So going on to our notes here, the second thing. So here's our objective for our lesson is at the end of taking notes, I should be able to know how to find speed, distance, time, conceptually and mathematically. So going on from there, let's see what we got. Some reading here. Woo! Wow. Okay. Everything is always moving. Right now, your speed relative to the sun is about 100,000 kilometers per hour. And you are moving even faster relative to the center of the Milky Way galaxy. When we study motion, what we are studying is the relative motion to something else. We discussed that. Ooh, there's our Milky Way galaxy. Let me get that back. Relative motion to something else there. And here's our Milky Way, right? Oh man, so we actually are located, if I use our little purple, here's our sun right here. So we're located roughly around there, and our Milky Way is moving quite quickly, but since we are on a moving planet, we don't feel that the Earth is moving. So, yeah, moving on. A little bit quick reading there. Let's see what we got. Speed. Let me get my little pencil up here. I want to be able to do some notes. Speed is the distance covered and the time it takes. The word per is divided by. So when we end up seeing like miles per hour, we're actually looking at the miles divided by the time that you're moving. I always think about it, obviously, with a car. We drive in cars, or we drive in buses, or we drive in something every single day. So we get that conceptually. So yeah. So I'm going to underline that. Per is divided by. If you were driving in a car and you covered 20 kilometers in 1 hour, your speed would be 20 kilometers per hour. And there's our per, right? If you ran 6 meters in 1 second, your speed would be 6 meters per second. The slash symbol is read as per. Okay, so our slash symbol here is read as per. A little bit of graphing with this. Now, so if we are looking at speed over time, or distance over time here, okay, what we want to be looking at is the time. Time is always on the x-axis. Speed, or distance, we should have to. Speed is always on the y-axis. All right, so those are really key factors. Now, why is time on the bottom? time is on the bottom because it is an independent variable. It's one that changes over a certain amount of time. So it's one that changes. Now, speed depends on the amount of time that passes. So we could end up having, you could be going in a car very quickly, and time is always changing. And that speed depends, for you to move up in time or to move up in speed, you need a certain amount of time to be able to do that. So that's why speed is always on the y-axis. So going through here, I've given some variables here for you to kind of graph through, and in your workbook you have them too here. So if I can end up just working through this here and just kind of clicking through to make sure that we get all of our variables. Now, I want to show. Ooh, no, I want to end up. Let me get through this again here. Click and click. So we got time and we have speed. Or title is always the dependent versus the independent. So what I want you to notice is that I have intervals, specific intervals here that go along with how I'm graphing here. So on the x-axis, I ended up showing that my intervals were by 2, and the intervals on the speed is by 4. So if you use 1s or 2s or 4s or 8s or usually evens, just be consistent. So let me just do a little bit of graphing just real quick here. So I'm going to end up looking at the first one here. Let me use red here. So here, 5 meters. Oh, you know what I'm actually going to do is that I'm going to use blue here. Blue for 5 meters. So if I'm looking at my speed here, my speed on this one. Oh, let me use green because I have green on there. My speed. So green is going to be 5 meters. So if I go to 4 and then 6, so it's going to be roughly around in between there. So it's going to be along this dotted line all the way across my 5 meters per second, and my 1 second is going to be roughly around right here. So I'm going to end up going through here, and it's where those two meet. That's going to be where my dot is going to be. Okay, so let me do another one here. 7 meters. I'll use green here. 7 meters, and then so if I go to 2, 4, 6, my speed is going to be 7 meters per second, and I'm going to have 2, 6, 7. So I'm going to have it roughly around somewhere in between there. So along this line all the way across, I'm going to be looking along that line, and then my 5, 2, 4, 6 is going to be roughly around right around there. So it's going to be right there. If you got any questions graphing, just come to me or give me a good shout. Email, or just come talk to me. Going along here for our individual work. So here I wanted us to discuss this guy here, the slope. Slope is really important. That's within graphing. And then also relationships. So these are two new words for you, inverse and direct. A direct relationship, if I'm going to write direct here, direct relationship with graphing. If we have a graph here, it is just that it goes straight up like that. Inverse, on the other hand, inverse is where the graph ends up going downwards. Okay, so it means that your y-axis is going down in numbers and increasing in the x-axis, and direct is always where it is increasing in the x-axis and it is also increasing in the y-axis. Okay, so if we're going to just do one of these problems here for your individual work, circle if the graph is inverse or direct. Well, I just showed you that, so this would be direct. And our average speed. We need to use the slope to find that. So if I end up, so my y-axis, so here's my y, and here is my x-axis. So my y, I'm going to have, I can do, so y2. So this is going to be my y2, and this is going to be my y1. So I'm going to have 40 meters minus 10 meters over, okay, so now I need to find out where that 40 went. So it's here, and it's going to be at 4, and my 10 is going to be at 1. So I'm going to have 4 units seconds minus 1 second. Okay, so what's 40 minus 10 is 40 minus 10, I end up having 30 meters. And then 4 seconds minus 1 second, I end up having 3 seconds. 30 divided by 3 is 10. So my answer is going to be 10 meters per second. Bam. That is going to be my average speed. Direct. So any questions on that, you just let me know, and I'll help you through it. All right, so our final thoughts here, okay, so is that I want you to work on that mathematical relationship of variables, your speed reading and questions, getting a little bit more accustomed to some keywords and some concepts, and work on those motion graphs. And let me know if you need any help. And I will see you in the next video.